I'd like to take a few minutes to talk to you about Chapter 3. So you should be starting on Chapter 3 today, and Chapter 3 is on communicating a local network. So I thought I'd take a couple of minutes and talk to you about some of the concepts. I thought that might be a little bit easier for you with so much content within this chapter. So I'm actually looking at the online content here, and the chapter is actually talking about communication, so communicating on a local network. And the beginning of this chapter is doing a comparison of your human network, which is a conversation between two people, as you would know, and how that compares to a computer network. Now, there's a lot of the same things in common, such as having someone to initiate the communication, having someone else to be the receiver of that communication, as well as some type of medium in between. If you really think about a telephone, the telephone network is the basis for our computer networks that we have today. Think about the components of a telephone network. With a telephone network, you have someone to initiate the phone call. You have someone who actually answers the phone call, so the receiver. Then you have some type of communication medium between the two of you. And then the other thing you have to have is a protocol. Now, if you think about what a protocol is a set way of doing things or a procedure that needs to be put in place. And when both parties involved are speaking the same language or using the same protocol, then you can effectively communicate. So you have a source, you have a medium, you have a receiver, and you have a protocol. So those components are important when you're referring to a communication network, whether it be through two people, whether it be a telephone, whether it be a network. Okay, so you have to have those things. And among some of the things that protocols include are listed here. So identified sender and receiver, so that could be with an IP address. The method of communicating, so how are you going to communicate, whether it's going to be face-to-face, whether it's going to be phone. Your common language, speed and timing of your delivery. So with this, making sure that one person doesn't communicate faster than the other person can understand. With your common language, both people have to be speaking the same language. If one person's speaking English and another person's speaking French, you can have all the other communication components, but speaking two different languages, it's still not going to be effective communication. And then one of the other components is the confirmation or acknowledgement. So if you're talking to someone in person and they stop talking to you or they turn their back or walk out of the room, then you know that they're not communicating with you. On a communications medium or a data network, it's harder to tell if someone has lost communication. So there are different things put in place, such as acknowledgments for data, that tend to help with that. All of those, or a lot of those things, are actually listed here on the next slide, which is the 3113. So the timing of your data, the message size, determining how much information you're going to send at one time. Encapsulation, okay, when data is sent, there's more than just data actually sent on a network. So there's a lot of information that's included with the data, such as the source and the destination IP addresses, their source and destination MAC addresses that are included with that. Information to separate the various protocols that are being sent, because we no longer use one network for each thing that we're doing. So for example, we don't have a telephone network and then have a data network and then have another type of network. They're all combined into one, and you've probably seen that term convergence. So a converged network includes all the different types of networks in one medium. If you have a converged network, you have to have some way to separate the conversations that are occurring, or the different types of technology. For example, if you are using your email, okay, you may be using email and instant message and surfing the web. You may be doing all that on your computer. You may be doing more than that. but all of that information is put together on one medium. Now, once it gets to the other person or the other computer, then those have to be separated. So that's where port numbers come into play, and all of that, that's part of the encapsulation process, the information that goes with your data. So your message format. Okay, so protocols define what type of format or the formatting that's going to occur when it's delivering a message. So that's included here, as well as your different types of encoding. So are you using pulses of light like you would use with fiber optic, or is it electrical channels that you would use with copper-based mediums, or you're using wireless, as you can use wireless signals, and message patterns. Okay, so this would be some messages require an acknowledgement, some don't, so you're going to just kind of have all of that information laid out within a particular protocol. And when two different communication, I guess, ends, if you want to call it that, so one interface and another, when they're communicating, they will have all of this information defined ahead of time, so everybody knows what's involved. The internet follows a set of rules or procedures, and that is going to be the TCP/IP protocol suite that you'll read about a little bit later in the chapter. But the internet has been around a lot longer than most people think. So the internet's been around since 1969, but it's not the internet that we know today. The internet we know today is used interchangeably with the World Wide Web. Okay, the internet that was initially developed in 1969 was actually developed by the Department of Defense, and back then it wasn't quite as cool as it is now, because you had to actually type in the commands. And now we have the World Wide Web. The World Wide Web is what allows us to have all these visual things that you get to click on and kind of surf the web. So with that, a lot more people started actually using the internet because they weren't actually having to type out commands to get everywhere. So one of the other things that allowed this explosion of the internet around 1990, 1991, when the World Wide Web was developed, was the fact that everything was more standardized. Prior to that, over the years, everything was proprietary. So when something is proprietary, one company owns something, you have to purchase additional items specifically from that company. Well, with the standardization among the various vendors, it allowed for that standardization so other companies could follow a standard set of rules if they were, say, creating a network interface card, or they were making computers. Everybody kind of followed the same guidelines. Also with that, we have some of these various companies that helped us create standards for cabling, for example. So if you have a cable plugged into the back of your computer, you know how it's going to be wired according to the standard that it follows. Or wireless standards, for example. If you go out and purchase a wireless router for your home, then you know the standards for that wireless router. Now, this is an example of a protocol stack. So TCP/IP is what's used to transfer things on the internet. And with that, for example, this is the way you would look at this protocol stack. So this is a server. So think clients and servers. A client is going to be requesting information from a server. So if you're requesting information from a server, you would go in and type http:// whatever. That's going to use the HTTP protocol. Then it's going to use the TCP protocol. TCP protocol will segment those messages, break them down into smaller sizes. It will actually correspond with the destination device and send acknowledgments, for example. It will also number the items so that if things have to be reordered once they reach the destination, they can be put back in the same order. And the TCP protocols also what lets you know if, say, an email didn't get somewhere. You get the message responding back saying it was not delivered correctly. The IP protocol is what is used for your addressing, so your IP addresses. And then you get down to your Ethernet protocol. With your Ethernet protocol, this is where you're actually referring to, say, your MAC addresses are included in this. At this bottom layer, this is where you actually have your NIC. MAC addresses are within the ROM, or read-only memory, in your NIC. And then you have your cable plugged into that. So you interact with this TCP/IP, or this protocol stack at the top. The message travels down. Once it reaches the destination, it's received as on that cable, and then starts traveling back up, and it strips off all that extra info that it's added down as it went down. Okay. So here is some more specific information about the TCP/IP protocol. So again, this represents the data to the user. The transport layer, think about its name. The transport layer is just what it sounds like. If you work in transport at the hospital, your job is to transport or take somebody from point A to point B, and there's no way you're going to show up without the person that you started with. You're going to let somebody know if something happened. Okay. Your transport layer is that the transmission control protocol that we were looking at. It works at this layer. The internet layer, that's where the IP addressing occurs. So it's going to determine the path and give the addressing that's needed to send data. And then your network access. Again, this is where your NIC is. Okay. So again, as you send something, it's going to use a protocol. That's how you're going to kind of interface or interact with the network. And then it's going to be segmented down. So that data is going to be segmented, and that's where it's going to be passed down to your internet protocol. That's where your addressing is going to occur, and then it goes down to this network access layer. That's where your MAC addresses will be added, and then it's actually the data is going to hit that medium, and at its most basic level, all a computer understands, computers being routers and switches and other networking devices as well, all they understand is ones and zeros. So ones and zeros are what's going to be traveling along whatever type of media that you're using. Once it reaches the destination, it'll be received at the bottom, okay, as ones and zeros. The MAC address will be checked. Then it will go up and check the IP address to determine it's at the correct device. Then, if data's been segmented and it might have been sent in a different order, when it gets to the destination device, it'll be put back in order. Okay, and then it reaches your application layer. So, and that's when you actually read the web page. So that's in a nutshell how your TCP/IP model works here, which leads you into the reference model. So I will kind of end here, and I'll pick up the next video talking about your OSI reference model, just so that it's not quite a such a lengthy presentation.